Hello, this is Mr. Manley. In this video, we're going to look at sums of radicals. I have 5 examples here. In order to add radicals, they need to be like terms. Of course, looking at the square root of 48 and the square root of 27, they're not like terms. Where are we going to go with this? We are going to simplify each of the radical terms in turn. Looking at rad 48, that is going to be the square root of 16 times the square root of 3. And then looking at the square root of 27, that's the square root of 9 times the square root of 3. What I'm doing there is I'm just thinking about, well, how could I factor this? What are some multiples of this? With 48, I could have said 6 and 8, but those aren't going to really help me. It wouldn't completely get in the way, but it was just convenient that I noticed that it was the square root of 68. If I did 6 and 8 like that, I would have to continue to break it down to find some sort of matching factors. So I'd have to go 2 times 3, and then 2 times 4, and then I'd go, okay, I've got a pair of matching factors there, the 2 and the 2. I know the square root of 4 is 2, so I would be able to proceed. You would be able to proceed if you didn't see 16 times 3 the way that I did. So the square root of 16, of course, is 4. The square root of 3, is left. And then plus the square root of 9 is 3. Now you see I have like terms. They're both some multiple of the square root of 3. I've got 4 square root of 3's, and I've got 3 square root of 3's. I add them together like I would any like terms. For instance, if I had 4x plus 3x, I would say that's 7x. That's the same idea with these. I've got 4 of these, 3 of them, so now there's 7 of them. 7 rad 3. And that's example 1. We're going to move on to another one here. Here we're going to be working with a cube root. And let's see what we've got here. You can do some inference here, right? Looking at this expression or this collection of 3 terms, I'm not going to be able to do anything with this. So if I'm going to have like terms that I can add together, it's going to be going in this direction to the cube root of 2. Let's see what I can do here. All right, well, I'm just seeing 5. 5 times 27. And then I'm seeing 8 times 5. And I've got the cube root of 2. No, maybe I was wrong. We're not going to be going in this direction. We're going to be going in a different direction. What have we got? You see I've got the cube root of 27 is 3. And then I'm left with the cube root of 5. The cube root of 8 is 2. And then I'm left with a 5. And those are my like terms, my cube root of 5 terms. I've got a like term there and a like term there. 3 minus 2 is 1. I've got 1 cube root of 5. And I didn't do anything with the cube root of 2 there. So that's it. Let's look at some fractions. Square root of 7 over 2 plus the square root of 8 over 7. What do we want to do here? I think the first thing we're going to want to do is rationalize the denominators. Okay? So I've got the square root of 7 over the square root of 2, square root of 8 over the square root of 7. Rationalizing the denominator, I would multiply this by square root of 2 over square root of 2. And the second term, I would do rad 7s. Then I've got rad 14 over 2 plus 8 times 7 is going to be rad 56 over 7. Now, I could probably, I think I'm going to be able to do something with that 56, am I not? 4 goes into that once, 4. So I could do something with that. Let's hold off. Well, we'll do it maybe in one step here. First of all, I'm going to get a common denominator. So do you see I'm getting a common denominator of 14. And that'll give me 7 rad 14 plus, I'm going to go ahead and as I go through this step, I'm going to simplify the rad 56. I'll go off and do that to the side. So that's rad 4 times rad 14. 4 times 14 is 56. And the square root of 4 will simplify to 2 rad 14. Remember, that's just this piece. Rad 56 is 2 rad 14, and then I'm going to multiply it by the 2 as well. And that will give me 4 rad 14, and remember we had the denominator 14. Look here, we have like terms. Rad 14, rad 14. How about that? 7 plus 4, I've got 11 of them over 14. I'll take a peek here and go, can I simplify there? 11 over 14? No. And that's simplified. Two more examples. Let's look at this. Simplifying this. Look what I'm going to do here. I'm going to distribute the square root of 15, but look at how I'm going to do it. And yes, look at this. I've got rad 5, rad 3. That's equivalent to the square root of 15. Times 2 rad 3 minus rad 5 rad 3 times rad 5. Follow that? I broke up the square root of 15 to square root of 5 square root of 3. And that was useful here as well. I didn't have to do it here as well, but it was useful. Now look at what we've got. Square root of 3 square root of 3, that's 3. The square root of 3 times the square root of 3 is 3. 3 times 2 is 6. And that gives us 6 rad 5. All of that is from this. That is 6 rad 5. Now I've got the minus. Rad 5 times rad 5 is 5. And that'll be rad 3. 5 rad 3. No like terms. Can go no further. That is that. Good. Let's look at one more example. You need to be flexible with radicals. There are variations on what you can do. Choices can be made. There are multiple paths. You need to practice them. Practice and work on finding the most efficient path. So I can do some simplifying here, right? Square root of 12, that's the square root of 4 times the square root of 3. Square root of 50 is the square root of 25 times the square root of 2 over square root of 2. So we've got 2 rad 3 plus, up here we're going to have 3, and then the square root of 25 is 5. 3 times 5, 15. 3 times 5, that's 15 rad 2. We want to rationalize the denominator. That's going to be rad 2 over rad 2 to rationalize the denominator. Let's distribute. I'm going to distribute the rad 2. That will give me 2 rad 6 plus, and then when I distribute, so I distribute this to here, and then here, I get a rad 2 times rad 2, which is 2 times 15 will give me 30. Over 2. Not done yet. Need to simplify this. Now look, you cannot cancel this. Please know that you cannot do that. Oh. Know that you cannot do that. Let's go back and erase that. Very wrong choice. There, there. So we still have the 2. Can't get my pen. There it is. All right, so we still have that 2, and we had that 2 there. Okay, so what can we do? I can factor a 2 in the numerator, like so. See that? 2 times rad 6 is 2 rad 6. 2 times 15 is 30. Now factors, I can cancel. This 2 is a factor of this, and then that 2 is its own factor in the denominator. These I can cancel. There, there, and that leaves us with rad 6 plus 15. And that's what we've got. So there are multiple choices to make that can work. There were other ways to move forward with this. But, so that's nice that there are options, but also that gets people choosing options that actually you cannot do. And if you're ever in doubt, sometimes it just helps to think about a simple case. If I want to know 2 plus 5 over 2, if I think, can I cancel those? Can I cancel those 2's? And then what would I say that equals? Does that equal 5? Or does that equal 5 plus 1? I don't even know what it would be. Would it be 5 or 6? But regardless, neither 5 or 6 makes sense, right? Because I know that 2 plus 5 over 2 is definitely 7 over 2. I know that's right, which is 3.5. So whatever I'm doing up here and whatever I'm getting there, it's not 3.5. So you see what I mean? If you want to think about, can I do something or not, if you can get a simple example to look at, maybe that'll clarify it for you. Practice is always good, but you also want to practice intentionally and keep reviewing your properties of radicals.